Welcome, flight crews. Welcome to the Angle of Attack Boeing 787 flight work training. We're excited to be here and bring this to you. I approached Chris a while back when I heard that Quality Wings was doing this, and they're coming up and developing the 787. I've been a Boeing 737 guy for about 15 years. I've been studying that aircraft, so to switch over to a 787 was a big jump for me, but one that I'm really excited about, and we're excited to bring this to you. I'm your instructor. I'll be your host and instructor for the rest of your course here, and my name is Jason Sokolov. You can contact me at Jason AOA 737. Both that's on Facebook and or Twitter. I'll be happy to answer any questions you may have. So let's talk about what flight work is. Now, flight work is just a series of lessons that we're really going to teach you, the viewer, how to fly the aircraft using basic techniques. We're not going to really go into depth on the systems yet and stuff like that. We definitely will, but that's going to be in a later series. We're definitely going to do a groundwork, 787 groundwork series, and the line work series. And if those are customers who are familiar with the line work section on the 737, it's going to be the same thing for the 787. We're really going to get dialed in onto how to operate the aircraft and the intricacies and that kind of thing. So stay tuned for that. That's going to come after this section. So let's talk about what this lesson is going to do. And this is just an introductory. So let's talk about a summary of this. It's really going to discuss a little bit about the 787 and really what's needed from on your end, the user, the viewer. Told you my contact already. Please don't hesitate to contact me. Let me talk about a guarantee. Our guarantee is simply this. I am not professed in any way to be an expert on this aircraft. I'm in beta mode, which means constant review, constant critiquing, and constant learning. And that's how you got to look at me as well as you. I mean, we're in this together. We're going to learn together. But I'm excited to bring this to you. Now, the flip side of that is what is going to be taught is definitely researched, studied, and highly looked at. It's not just something on a whim. Let's just do a takeoff, because no, it's researched on how to do one properly. It's not only that, but it's studied and reviewed. So that's our guarantee. That's my guarantee. I'm going to bring you the best I can, and if I don't know the answer, I will get you the answer for sure. So studied material, definitely research content, that's a big deal. And we're trying to bring you professionalism the best we can as well. I don't necessarily do a great job of that, but sometimes I try, right? Okay, so let me ask you this. Why the 787? And Chris has approached me with the 777. And I really, really wasn't interested. This was a while back. And the reason why for that is it was a long-haul aircraft. And I went, I really don't like flying many hours sitting there. And I just didn't have time for that. Another thing is I really didn't want to study a new aircraft. And be honest with you, I was comfortable in the 737. I studied it all the time. I still do. I look at it all the time. I want to learn a ton of information about that aircraft, and I studied 15 years on that one type. So to jump to another one, and the way I am, I think you guys know that, the viewers that have seen me, I'm all in, and I'm committed, and that's what I was a little hesitant on. I was like, man, I just don't want to commit, because when I'm in, it's 100%. There is no throttle back. It's not 75, it's 100, unfortunately. But fortunately for us, I'm excited because this aircraft really excites me, and I'm excited about it, and we're going to talk about why. Now, the reason I fell in love with this airplane, and I'll tell you why I did. I went to Boeing recently in Seattle, and I had the opportunity to come face-to-face with the 787, nose-to-nose with it, feel the engine, feel the aircraft, look inside the airplane, walk through it. And I tell you what, I was absolutely floored by the technology. And I said, you know what? I'm committed. We've got to do this. And that's why we're bringing you the 787. And I'm grateful for Quality Wings of producing a great aircraft to bring you one. I think you're going to love it. So it's a modern-day technological marvel. That's why we're doing this. That's number one. It's got power and efficiency rolled into one aircraft. So think about Lamborghini, Cadillac, you get a 787, right? It revolutionizes air travel, I think, especially in the cabin, in the back end. The passengers really feel different when they fly this aircraft. And those of you who have flown in it, you probably know, like, yeah, I feel less fatigued. And there's reasons for that. All right, so great, beautiful airplane. It's clean lines, clean wings. And we're going to get into that a little bit more. Now, let's talk about 787 details a little bit better on why I'm so excited. Number one, it's got highly advanced systems, a huge cargo capacity, lower pressurization in the cabin. As I said, it was revolutionized for the cabin. To give you an idea of what that is, like a 737 will probably top off at about 7.5-ish to 8, 7,500 feet of cabin altitude, right? Well, the 787 is 5,000. So it brings it up, and you can climb the 43, it's going to 5, a little above it. But amazing that it can do that and lower that cabin pressure. That's why we're less fatigued. Crew rest areas, it has multiple crew rest areas in the front end and the back, just kind of like your 777. Another thing that floored me is it's mostly composite material. Now, being old school, I'm old school minded. Metal, we know about metal fatigue. We know how metal reacts. Composites, well, we've had about a good maybe 40 years of composite study, if you will. And it's been really good. A composite material actually is stronger than metal, which is interesting. And the engines are absolutely efficient. Again, I'm floored by the technology of this aircraft. So that's just a little about why and Boeing 787 details. Now, 3 classes, it's actually 4 classes. We're going to talk about that. The Dash 800, which we're going to fly, the 300 and the 900, and they just released the 10, and we'll talk about that. Now, the Dash 800 seats about 223 passengers, give or take, in a 3-class configuration. I looked at like 250s, but the mile range is 8,500 nautical miles. So, not a lot of people, but really long. And the 777 is a lot of people, really long. So the difference was Boeing said, how are we going to fit a replacement for the 7.6 and 7.5 aircraft? And this is what they've come up with. Almost more on the 7.6, but be 20% efficient. More efficient than that particular airplane. Long, thin routes. And that's what we're going to talk about mostly what the 787 is designed for, is that long, thin route. Now, I'll give you an idea. San Francisco to Beijing. Or San Francisco, to Bangkok. Something that's not very, when you think over, let's talk about over the ocean, Europe, you're thinking, London or Paris to New York. Well, think this, Paris to Texas, Austin, Texas. You're not going to fill an aircraft full of 400 people. It's just not going to happen. But you can definitely get about 220. And that's what the 787 does. Now, the Dash 300 fits a little more, 269 passengers in a 2-class configuration, but the mile range has dropped, 3,500 miles. You're looking at a 737. The Dash 900, more people, 259 in a 3-class configuration, 8,300 miles. And the Dash 10 is going to fit a lot more people and a lot bigger range. I don't have those data points up. But for right now, Quality Sims have released the 800 and both engine configurations, Rolls-Royce and the Gen X. And like I said, it has really created more non-stop routes for the long, medium haul range, long, thin routes. And the airlines love them because they're able to make money on that little capacity. That's been very good. Now, let's talk about some systems here. Reduced fuel burn because of a few things. The engines, the aerodynamics, the materials of the aircraft, and actually the systems. 4 things that really make this aircraft such a modern-day technological marvel. First of all, let's talk about the engines a little bit. There's two engines. Like I said, there's two engine options, the Rolls-Royce and the Gen X engines. A really high bypass ratio of 9.3 on takeoff. Now, that's bypass ratio, okay? 9.3 on the takeoff. I believe at cruise it's a little lower. It goes to about 8.1-ish. Now, the 737 is 5-to-1. So you're looking at 5 versus 9. So very efficient. Basically, what it does is it takes high flow. So it grabs a ton of air at a lower fan speed. That's what makes these engines so interesting. High amount of air with low fan speed generates a lot of thrust, a lot of power with not a lot of fuel burn. Now, one other interesting thing about this particular aircraft, and we're not going to get into systems heavy on this lesson, it's just an introduction. We will in the sections after, when we talk about groundwork, we're going to get into the systems pretty good. This engine is a no-bleed system. I'll say that again. It is a zero-bleed system. And we're going to talk about that here in a little bit, I believe. And it's a low noise, very low noise, because there's such high flow. You don't need all that power. Okay, now as I said, the lifeblood, I was talking about the engines, a little bit more about that, and I was kind of alluding to this earlier. The lifeblood of any aircraft is what? Just think about it. What sustains life in a jetliner? You got it. It's the engines, right? The engines give us heat, cooling, pressurization, anti-icing. Well, eliminate all those systems now. The lifeblood of this aircraft is not the engines. It's actually the electrical system, which is amazing. So I'm going to bring up this picture and talk about the aerodynamics. Now, I took this picture at Boeing. I walked through this aircraft, and I was with a friend of mine. The first thing I said, and I noticed when I looked up into the cabin, got in the cabin, looked over the wing, and the first thing I said was, I cannot believe how clean this wing is. And he kind of looked at me with funny, what are you talking? It's such a clean wing that it floored me how clean it was. And there's got to be a reason for the cleanliness of this wing. And I'm not talking about dirt. I'm talking about parasitic drag. There was none. And I was wondering why. I did research on it. There's 50,000 or so less rivets in these wings than a typical airplane, than the 767s. 50,000 less rivets. That makes for a highly efficient wing. Not only that, but it does not want to stop. This wing is so efficient. This aircraft actually had systems designed to actually slow it down. And I'm not talking about flaps either. That's your traditional. This is non-traditional stuff they've done. It's called an auto-drag system to actually slow the aircraft down. We'll talk about that in a little bit. It's really an advanced wing design for the speed and lift. It's such an efficient wing. The entire wing becomes a flap for improved landing speeds, as I was saying before. It's got an auto-drag system. So if we're high and fast on the approach and we're coming down the approach, we slap the gear down and throw flaps in. The actual ailerons are actually drooped. They're curved like this. And they'll actually come down and drop. And if you look at an overwing, the whole wing is a flap. That is impressive. The whole trailing edge of the wing is a flap. You'll never see that on a traditional airliner. So the flaps, the ailerons actually droop down, the flaperons come down. It's just an amazing piece of technology. Less weight and drag by a clean wing design. As I said, there's 50,000 less rivets in the thing, which helps for clean, no parasitic drag, and less weight. So let's talk about composites. Now, like I said, composite material, this aircraft is almost 90, I forgot the percentage breakdown, but it's in the high 90s of the composite material. The entire wing section, most of the wing section, is carbon laminate, which is amazing. The whole wing is carbon fiber. Okay, again, unheard of today. It's all usually metal. The engines itself. So let's talk about the engine cowling. It's carbon sandwiched. Obviously the intake is aluminum. The engine itself is aluminum. However, the engine fan blades are carbon fiber. They're carbon laminate. Yes, I'll say that again. The front of the fan, the N1 fan that spins, is carbon fiber, with aluminum, leading edge. Well, that's amazing. Again, that's another thing that I just went, huh? Like, wait, what? Stronger than metal. Remember that. It's stronger than metal. Some aluminum components on this aircraft, but let's talk about the carbon footprint. The carbon on the aircraft. The entire wing section is carbon laminate, either carbon laminate, carbon sandwich, or other composite material. The only thing aluminum on this airplane is the front end, the engine cowl, the engine fan blade, just the front of it, leading edge. The leading edge of both horizontal stabilizer and the vertical stabilizer, that is it. The rest is different. Now, the only thing titanium on this aircraft is the back cone of the APU exhaust valve. That's titanium. And then the engine pylon is an other material. I don't know what that other is. It might be kind of a different metal alloy on it. I'm not certain. I'd have to get you that answer. So most of this aircraft is composite material. All the control surfaces that we use are all carbon sandwiched or carbon laminate. Again, an amazing piece of technology here. And to give you an idea, when ANA was looking to order these, they're a launch customer for the 787. They said, how's it going to do on the ramp? Because if you puncture carbon fiber, guess what? It's not like metal. You can't just throw a patch on it, throw rivets. You can't lap joint it. It doesn't work that way. You have to actually take a section out. And it's just a terrible thing, because then you get this carbon that has that interlocks and weaves. You get that delamination occurring, and it actually pulls apart like that. That's not good. That's not what you want. So ANA said, well, what about hanger ash? And Boeing sent them a section of the fiber of the fuselage, the carbon laminate, and they said, here's a hammer, and here's a section. I want you to hit the thing as hard as you can. And they just sat there and pounded this piece with a hammer. Couldn't even dent it. And they went, whoa, if that was metal, it'd be ding, 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 you know what I'm saying? It'd be dents all over the place. Now, if you take a tug and you go at 25 miles an hour and you slam inside of the aircraft, yeah, it's probably going to puncture the skin. But the skin's pretty thick. I looked at it, it's probably about that thick on the side, so it's pretty thick carbon. Let's talk about some more advanced systems. Like I said, the electrical system is the lifeblood of the aircraft. It's not the engines. The life-sustaining systems are actually electrically driven. The flight controls are drooped, as I said before, making for a highly efficient wing on the trailing edge. It's a fly-by-wire aircraft, obviously. It's fly-by-wire enabled. Most of them are today in this day and age. And the integrated navigation communications are really in one package. They reduced a ton of systems on this aircraft by just making it electric. A lot of these things are electrical. You don't need pulleys and cables anymore because it's all fly-by-wire. Okay? Which, again, for me, it's, do I really like that? Well, yes, I do. And we're going to get into the systems later. I don't really want to talk about it too much now, but that is it for this introduction. One thing I will talk about really quick is what you're going to need. And we recommend EasyDock is one of those things. And we'll provide a file where you can just load it into your EasyDock, and all the views that we use, you can use as well. And that'll be easy for you. And the actual control setup of the aircraft is done by FSU IPC. You can do it that way, or you can do it the way you're used to and want to. That's fine. Either way, just get it configured. If you're going to use EasyDock, erase every single prompt in your flight controls menu in Flight Simulator. Just erase every single prompt, and that will help you so you're not messing it up with EasyDock, okay? That should be it for this lesson. Again, it's the end of the introduction. The next lesson we're going to talk about is we're actually going to get inside the aircraft, and we're going to do a cold and dark start. We're not going to actually start the engines. We're just going to do a power up. We're going to take you through different flows and different sections of the aircraft, all the way from cold and dark start to fire it up, engine start, taxi, climb, descent, landing, and that's it. So you can land the aircraft confidently. And again, that's the basics. That's what FlightWorks about. Let's get in this aircraft. I'm sure you guys are excited to do that. So until next time, throttle on.